Data mining Coursework1 by Team Wuhan. So for business objective, we need to get familiar with basic function of Weka and machine learning and extract information from data and identify offensive tweets. So for data mining objective, we need to create ARFF file and explore classifiers to measure the goodness, which means how well the classifier is to make a good result. For success criteria, we providing the specific evidence, which is clean data, an example of classifier output, an analysis of performance, and some screenshots for the result. The coursework provides a default training file which we split according to 3 different test files, and the data consists of 2 types of attributes and 1 class attribute. Because tweets are all unique, it's impossible to predict class by using the whole string, so we solved it by using string-to-word vector filter. If it exists, some strings are not relevant, so we just delete it to make it clear.
Okay, so data preparation. So we mainly used the Atom IDE to clean data. We also had to identify outliers, for example, multiple commas between the attributes, absence of double quotes for a single tweet. We also had to put every single tweet in the quotation marks so it is recognized as a string by Weka. And finally, we had to fix all the minor errors, remove unnecessary quotation marks, and so on. So data transformation. We used online tools to convert training and test sets from TSV format to CSV format. Then we manually combined test set files with their corresponding labels together, and it was easy to do by using Microsoft Excel. Finally, we manually converted training and test sets from CSV format to IRFF format. So this is one of the examples how our test set IRFF files look like. So the last thing we had to do was to select features. So our team has used 3 different classifiers to predict labels of the test sets. We also had 5 different possible labels, and our data had 3 attributes. We did not need to split anything into the train on test pods because the training set and the test sets were already provided.
To build our models, we used the filter classifier on various classifiers from different categories, such as base, function, rules, and tree. The only filter we used was string-to-word vector to convert text to numerical values. We also used additional parameters such as minimum term frequency and n-gram tokenizer, which group words together in an attempt to improve accuracy of our models. We have found that the minimum term frequency does not affect the outcome in any way, and hence we will not be showing it in subsequent slides. We also train our models using training data, percentage split, and cross-validation to see how it will affect the accuracy for different classifiers. Here are a few outcomes from different classifiers. For subtask A, determining whether a tweet is offensive or not, BaseNet returned an accuracy of 79, while naive Bayes multinomial returned 71, which shows that BaseNet was more ideal. We also tried the SMO classifier, and as it returned a pretty high accuracy, we used the n-gram tokenizer to see if it would improve the accuracy. But as you can see, it didn't. Here you can also see that naive Bayes multinomial returned a poorer accuracy when using the n-gram tokenizer for subtask B. Here are the results for subtask C, and you can notice that the accuracy improved slightly of 0.5% when using the n-gram tokenizer for BaseNet classifier. While using the naive Bayes multinomial classifier, the accuracy improved significantly by 3% when the n-gram tokenizer was used. It became better at predicting class A and C, but got worse at predicting class B.
Here you can see which classifier was the best for each subtask A, B, and C. Different classifiers were most accurate for different tasks. For the task A, the best classifier to identify was SMO, with a precision of 81%. For the task B, the results of almost all previous classifiers was better. The best one was for 1R classifier, getting 89% precision. For the last task C, the results were worse than in previous tasks. We assume because more labels had to be trained and tested. The best classifier to identify the label for the tweet was BaseNet, with 61% precision. Since we set business objectives responsibly and the requirements for the project were selected as the coursework task suggested, the project met almost all business needs. All the data were classified with found and investigated key, tools, and features.